Alrighty, guys, we're looking at the IM1 Patterns Day 4 notes. So we're starting with this warm-up. Looks like it has a common ratio since the numbers do not have a common difference, right? So it appears that we are multiplying to get from one term to the next, one term to the next, one term to the next. It appears that we are multiplying by 2. So when asked, what do you notice about this sequence? Some responses that happened in class were the numbers are increasing. Some others said the common ratio is 2, or in other words, we are multiplying by 2 to get to the next term. Others said the initial value, or the first term, is 6. And actually, we just answered number 2, didn't we? The common ratio and the initial value. So that's probably pretty good. There are no wrong answers there. You need to check it with your teacher. If there's something else that you noticed, reach out to them and ask. But otherwise, that's kind of what we were looking for numbers 1 and 2. For number 3, what would the next 3 numbers in the sequence be? Well, you would just keep on multiplying by 3, it looks like the ratio is 2. Multiply 48 by 2, multiply 96 by 2, etc., and just keep on multiplying by 2. Now, how is the above sequence different from the first sequence? This sequence here is decreasing, right? So we're getting smaller and smaller and smaller from one term to the next. What would its ratio be? Its ratio is 1/2. You may be thinking divide by 2, but that's the same thing. So you are dividing by 2 to get from one term to the next, from 48 to 24 to 12, and so on. But what you're actually multiplying by is 1/2. So multiplying by 1/2 is the same thing as dividing by 2. What would the next 3 numbers be? Well, you would divide 6 by 2. That would give you 3. You would multiply 3 by 2. That would give you 3 halves, or 1.5. And then you would multiply 3 halves by 2. And that would give you 3/4, or 0.75. All right. Now, jumping on down, we are identifying independent and dependent quantities today. That is one of the things that we are focusing on. And our learning goals is we are going to actually graph sequences and model sequences today. So what we did in class here is we asked to determine, well, actually, we made these numbers up. So the term numbers are going to be 1, 2, 3, 4, and 5. We took a number, let's just say 5. We're going to make something up. And a common difference of, I don't know, let's just go 7. So we're going to add 7 each time. So as we add 7 each time, that's going to give us 12. It's going to give us 19, 26, and 33. So we have our first 5 values. Now, what would the formula for each of these sequences look like? Well, let's do arithmetic first. Let's knock that one out. So for our arithmetic, remember we start with a sub n, and then we are going to take the value of the first term, which is 5, and then we are going to add the common difference, 7, n minus 1 times. So that's going to be our formula there. Now we made another one up for geometric. So we have our term numbers 1, 2, 3, 4, and 5. Let's start with 5 again. We have an initial value of 5, and let's just go with a common ratio of 3, so we won't get too crazy here. So 5 times 3 is 15. 15 times 3 is 45. 45 times 3 is 135. And 135 times 3, let's double check that really fast. What is 135 times 3? Some of you could probably do that in your head. It comes out to 405, though. So that's the value of our first 4 terms. So our geometric here is going to be a sub n is equal to the value of the first term multiplied by the ratio of 3 n minus 1 times, and make sure that you put that up in an exponent, right? So it's not going to be down on the ground like the arithmetic, because we're not doing repeated addition, we are doing repeated multiplication, so it has to be raised to an exponent. Let's see. One we could do here, for other would be something like 1, 4, 9. Let's see. Sorry about that. 9, 16, 25. So we can see that there's no common ratio here. We're not multiplying by the same number to get from one term to the next. It appears we are adding 3, adding 5, adding 7, and adding 9. So there's definitely a pattern here because it appears that there is a second common difference of 2. Okay, now this right here, this is IM2 stuff. So you're going to have to wait until IM2 to determine what that equation is going to be. So we'll keep you guys waiting there. Alrighty, next we are going to graph this arithmetic sequence here. So basically when you're looking at a table here, these are just ordered pairs, right? So you have 1, 5, 2, 12, 3, 19, 4, 26, and 5, 33. So when you graph this thing on coordinate axes, it's going to look something like this. And as you can see, arithmetics, when you plot the points and graph this, this is a line. Arithmetics make a linear equation, a linear function. And we're going to talk more about functions in the next season. Why don't you give the geometric one a try now? All right, once you have graphed the geometric, it's going to look something like this. And as you can see, the numbers here are much bigger than the numbers over here at the arithmetic, and that's because geometrics are actually known as exponentials. And exponentials, when you're multiplying, the numbers get big really, really fast. So this is kind of an approximation. It's tough to see where the 0.15 and 215 are, so we're just kind of approximating here. But you can definitely see for the 0.4 and 135, it's approximately where this point is. And then 5, 405, it's approximately where this point is. You can see that this thing is creeping upwards pretty quickly. Okay, so that's going to be known as an exponential. We'll get more into that next season as well. Go ahead and give plotting the points for the other a try as well. It's actually what's known as a quadratic, but again, you're going to have to wait for IM2 for that guy. And lastly, for number 3, I encourage you to go and do some research out there, looking up examples that can be modeled by an arithmetic sequence and something that can be modeled by a geometric sequence. There's all kinds of ideas out there. Maybe you start with $5 in your account, and you every week you save an additional $7, something like that for the arithmetic. So go out there, do a little research, see if you can find some real world examples, and good job. Make sure that you're ready. Go back and review those self-assessments and portfolios, make revisions because the test is coming up next. Good luck, guys.